Hi everyone, I am Balaji Chippada and welcome back to my YouTube channel. In continuation of our linear algebra series, in this video, let's learn about dot product. So let's say I have 2 points A, which is A1, A2, A3 up until AN. This is an n-dimensional vector. And in the last video we have seen that this first one is corresponding to x1 component, this one corresponds to x2 component, and this corresponds to xn component. And x1 x2 up until xn are the axis. I have another point B, which is b1, b2, b3 up until bn, and this is also n dimensional vector. Is that clear? Now let's say I want to have a vector called C in which it is the summation of A plus B. Then how I can do the summation? Then I have to take the corresponding position values. Then I would have to sum it up: A1 plus B1, A2 plus B2, comma A3 plus B3 up until AN plus BN. So this would be the sum of two vectors. Now when I say sum of two vectors, then you will have another question that comes into mind, which is how can you do product of two vectors, right? In linear algebra we have two types of products. One is dot product and second one is cross product. For the sake of machine learning, we will mostly not use cross product, we will only use dot product. So in this video we will learn about dot product in detail compared to the cross product. If you want to know or learn about cross product, please google it, but as a data science point of view we don't use cross product much. And some of you might have already learned these things in +1 and +2, but I will be rephrasing these topics again so that it will be easy for you to proceed with the data science courses. How a dot product is symbolized: so we have two vectors A and B, and the dot product will be marked as A dot B. So this is the symbol. And now let me give you the formula, which is A1 into B1 plus A2 into B2 plus A3 into B3 up until AN into BN. So this is the formula for dot product of two vectors in linear algebra. Now let's understand this in detail. So this is the formula. I will also explain the intuition behind it as well. Now let's summarize this formula. So A dot B equal to sigma, which is summation AI BI, and I will be going from 1 to n in case of n dimensional vectors. Is that clear? So this is the standardized formula of dot product of two vectors. Now in the previous video we have learned about row vector and column vector, right? Now let's bring those topics again and understand why it is important. So what I am saying, A dot B equal to A1 B1 plus A2 B2 plus A3 B3 plus up until AN BN. Now I will convert this into like this: A1, A2, A3 up until AN, and I will have one more matrix which is B1, B2, B3 up until Bn. Just hold on for a minute, I will explain all of these things in detail. So this is of shape n cross 1 and this is of shape 1 cross n. And if you remember matrix multiplication, how it will work? So this will be producted by this one. So it would be A1 B1 plus this would be multiplied by this element A2 B2 plus Likewise, this would be multiplied by this one, a and bn. So this representation is going to be the same as this one. Is that clear? So what I'm doing here, I have split this a dot b into two different matrices, and this matrix is a row vector and this matrix is a column vector. In the previous video, we have learned about row vectors and column vectors, right? If the shape is 1 cross n, then means it has only one row and multiple columns. So we call it as a row vector. And if the shape is n cross 1, then it has only one column but multiple rows. Then we call it as a column vector. Is that clear? And one more thing that I want to say is, in general, whenever someone specify a vector, then that means by default it is a column vector. Unless and until they specify it specifically as row vector, you have to take it as column vector. So let's say if someone says there is a vector a, that means this is of column vector by default. And if someone says a row vector a, then it will be looking something like this. So please remember, if someone says a vector of a of n dimensions, by default it is column vector. And if someone specifies it as a row vector, then only it is called as a row vector. So now let's take this example again. So let's say I have two vectors a and b of n dimensions. So that means a is a column vector a1 up until an, and b is also a column vector b1 up until bn. Clear? Now if I have to compute a dot b, which is a1 b1 plus a2 b2 plus like this an bn, this will be converted as a1 a2 an and b1 b2 bn. If you look at this clearly, this is a transpose and this is b, right? If you look at this a, what is a transpose is equal to a1 a2 up until an, and we have the b as it is, so it is basically like a transpose into b. Is that clear? If you have any queries, please let me know in the comment section below. And we have also seen that where a dot b is basically this one. So if I have to conclude everything, a dot b equal to sigma I equal to 1 to n ai bi, this is also equal to a transpose b if both of them are column vectors, if a comma b are column vectors. Now let's understand the geometrical intuition of a dot b. So let's say I have 2D plane. Let's assume I have a 2D plane. So I have like this x1 and x2. I have a point p1, which we'll call it as a1 comma a2, and I have another point p2, which is b1 comma b2. And what I would do is, I have this as 90 degrees, then I will connect this from the origin, and then I will also connect this from the origin. Now I will also say that the angle between these two lines is theta. Clear? Now we are going to learn geometric intuition. So what mathematically does is a dot b is equal to, let me phrase the formula, modulus of a, modulus of b, and cos theta. Let me explain what all of these things is. So this is basically the value or distance of a or p1 towards origin. So I will take it as a and I will take it as b. That will be easy actually. And this is basically distance of point b from origin. In the previous videos, we have seen the distance of a point from an origin. So which is basically, this is modulus of a and modulus of b. and this would be equal to root of b1 square plus b2 square. In the previous video we have learned, right, distance of a point from the origin, it is 0 comma 0, and this is basically root of a1 square plus a2 square. Clear? And according to the formula, a dot b equal to modulus of a modulus of b cos theta. And if I have to find the angle between these two lines, then theta equal to a dot b by modulus of a into modulus of b. Is that clear? And how did you come to this formula? You can do Wikipedia search. And if I have to explain all of these things in detail, it will take a semester long course, but whatever is necessary for data science perspective, I will be teaching all of those things. Hopefully that is clear. And we know this a dot b is basically a1 b1 plus a2 b2, because we have only two dimensional point, by root square root of a and modulus of b. So this is the theta. Hopefully that is clear. Now let's generalize the same concept in 3D. So what is the angle between multiple points in a n dimensional plane? It is basically a dot b by modulus of a modulus of b. Even if a belongs to n dimensions and b belongs to n dimensions. So this is basically sigma of I equal to 1 to n ai bi by square root of a1 square plus a2 square plus an square root of b1 square plus b2 square plus bn square. So theta equal to cos inverse of so we have seen, right, if it is modulus of b, that means distance of origin to the point b, modulus of a, distance of origin to the point a, and if my a and b is of n dimensions, then the value is like this. So this is how you will generalize or find the angle between two points in a 3D plane. Now we will learn one more concept, which is, let's say I have x1 and x2 and I have a point here a, and we'll call it as a1 comma a2, and I have another point which is b, and I will call b1 comma b2. So if I connect these 2 points, and if I assume that these two are of 90 degrees, then what is a dot b? A dot b equal to modulus of a. So this is modulus of a is basically distance of a point from origin, modulus of b and cos theta, and distance between angle between these 2 points is 90. So this would be modulus of a modulus of b cos 90. What is the value of cos 90? 0. That is equal to 0. So if a dot b is equal to 0, that means both lines are perpendicular. So what is perpendicular? Perpendicular means the angle between these two is 90. So if I have to generalize this for n dimensions, if a and b belongs to n dimensions and a dot b is equal to 0, that means both planes are perpendicular. Hopefully that is clear. If you have any queries so far, please let me know. So let's rephrase all the concepts that we have learned so far and understand it in coding part as well. So first we have 2 points a and b, which is of n dimensions, and each of the value is corresponding to a particular component axis. And then we have seen how to add both of these. So we have a1 b1, a2 b2, a3 b3, a and bn. And then we have seen what are the different types of product of two vectors. So we have dot product and we have cross product, and according to the data science we don't use cross product much. That is why we are using dot product, and dot product is defined like this: a dot b equal to a1 b1 plus a2 b2 plus a3 b3 up until a and bn. So this can be shortened by like this format, and then this can be rewritten in matrix multiplication format as well, like this. And we have generalized this into row vector and column vectors, and by default if a particular vector is not defined as row vector, you have to treat it as a column vector. And if I say I have two vectors a and b, and by default both of them are column vectors, and if I have to calculate a cross b, then it is equivalent to A transpose B according to this matrix multiplication. And so this is the whole formula actually, if A and B are column vectors. And then we have seen how to find the theta between both of these values. So A dot B is equal to mod A mod B cos theta in geometry, and mod A is basically distance of a point from the origin, and mod B is basically distance of a point from the origin, and theta is basically the angle between these two lines. So A dot cross B equal to mod A mod B cos theta, and theta equal to cos inverse of A dot B by mod A into mod B. And then we have generalized this for the n-dimensional data as well. So this is how you will find that angle between the planes in a n-dimensional data. And then we have also seen that if the angle is 90 degrees in a given planes or lines, then their dot product value is always 0. Now let's go back to the coding examples and understand what is happening. So I have two 2D points. So I have x-axis and y-axis, and 1 2 3 4 and 5, 1 2 3 4 and 5. So I have point 2 comma 3, which would be something like this, and I have point 4 comma 5, which would be something like this. So this is P1 and P2. So we will call it as A and B in this scenario. Now we are doing a sum vector of A comma B. So this would be adding these two values, which is 6 comma these two values 8. That is what we have learned, right? C equal to A plus B equal to A1 plus B1 comma A2 plus B2. And then we have dot product, which is A dot B is equal to A1 B1 plus A2 B2, right? So this would be something like 2 into 4 plus 3 into 5, and this would be 8 plus 15, which is 23. So the dot product is 23 and the sum of vectors is 6 comma 8. And to add all of this logic, you have to do np dot dot. So in Python we have this available, so you don't need to custom logic all of these ones. You can just do numpy dot dot. So we have learned the numpy in the previous videos, right? So that's how you can do it. So we have A, we have B, and then sum equal to A plus B, and dot product is equal to np dot dot A comma B. And if you execute, we get the output. Now I can replicate the same in 3D as well. Here I am giving points 2 3 4 1 0 minus 1, and I can just do the same thing, A plus B and np dot AB. Now let's understand this logically, and then let's see the results. So A plus B is basically sum of all of these things, right? We have 3 comma 3 comma 3, because we'll sum like this. And then if it is a dot product, what we will do, we will do 2 into 1 plus 3 into 0 plus 4 into minus 1. So this is 2 plus 0 plus minus 4, this is minus 2. So the dot product is minus 2 and the sum is 3 comma 3 comma 3. I hope that is clear. And I can just expand this for n dimensions as well, and this will work without any issues. So all you need to do is np dot dot. That is all you need to do while doing a dot product. Now let's understand the angle between 2 points. So what we have seen, A dot B equal to modulus of A, modulus of B, and cos theta. And if you have to find the theta, which is A dot B by modulus of A into modulus of B. What is A dot B? This is dot product. Dot product by modulus of A into modulus of B. What is modulus of A? Root of A1 square plus A2 square, right? So how do you calculate this? By using a function called np dot linlag dot norm. Hopefully that is clear. Now let's understand this output. I have created a function here, angle between 2 points V1 and V2. So first I am calculating the dot product, and then I am calculating the volumes. This is basically root of A1 square plus A2 square, and this is basically root of B1 square plus B2 square. This is modulus of A and this is modulus of B. So what I have to do? I have to do cos inverse of dot product of A comma B by modulus of A into modulus of B, right? So for cos inverse, we have a function called np dot arccos. So arccos. In this, I have to provide this one. What is cos theta? Dot product. This dot product divided by this normalization of v1 into normalization of v2, which is this one into this one, and then I am passing it inside this one. Is that clear? I'm just clipping. You can just Google clipping for numerical stability if it is not mandatory, but it is just a safety check. And then I'm converting this radians into degrees. Initially, when you calculate arc inverse, you get the value in radians. You can just Google what is radian and what is a degree. So let me Google it for you, some sake. Radian versus degree. So let's understand this. So let's go to images. So if you look at this one, so it is 90 degrees or pi by 2 radians. We call it as radian, and or we can call it as a degree as well. You can learn about a lot of these things by googling and all of that stuff, but that is not that much important for you. So I will just go back to this one. We have returning angle degree. So if I have 2 points 3 comma 4 and 4 comma 3, and if I have to find the angle between these two lines, then I would have to call this function by passing these two, create, and then I am just printing the value in degrees. So we have the 16.26 degrees. Let's plot this in 2D and understand whether it is correct or not. So I have 1, 2, 3 and 4. 1, 2, 3 and 4. So what is the first point? 3.4. So this is the first point. So this is this one, and another point is 4.3. So this is 4.3 and this is second point. If you see, this is theta. So this is somewhere approximately 16 degrees, right? So we calculated theta by using a dot product. Hopefully that is clear. Now let's understand dot product value is equal to 0. That means they are perpendicular lines. Now I have 2 points. Let's take this plane x1 and x2, and I have like this 1, 2, 3, 1, 2, 3, minus 1, minus 2 and minus 3. I have 2 comma 2 as a point, minus 2 comma 2 as a point. If I connect these two lines from the origin, both of them are having 90 degrees. And how am I going to confirm this 90 degrees? If dot product equal to 0, then this angle between them is 90 degrees. That means they are perpendicular. So what I'm doing here, I'm calculating the dot product, and if the dot product value is 0, then they should be perpendicular vectors, and I am also plotting them using a plotting method called matplotlib. We will learn about matplotlib in the next videos. So just for now, let's forget about that. And if you see, so this is my first line and this is my second line, and both of them are having 90 degree separation. If a dot b is equal to 0, then a and b are perpendicular, no matter what, if it is a 2D or 3D or n dimensions. And that's all for this video, guys. In this video we have learned a lot about perpendicular vectors, cos theta, dot product, a lot of other stuff, and we have also seen all of them in coding as well. So I will be providing the notebook and also this Google Colab notebook in the description below, so that you can get it for yourself and practice for yourself. If you learned something new from this video, a sub to the channel would be amazing, and click that bell icon to get notified daily. And we will meet in the next video. Bye bye.